In section 2.1, we're going to introduce functions, the basic building block of what we're going to be studying this semester. Most of this material should be review for you. Once we get through some of the definitions, we're going to look at examples, figure out what makes a function, some properties of functions, as well as some different operations and things associated with functions. But before we can define a function, we're going to define something a little bit more general than a function, and that is a relation. So a relation is just a correspondence. It's a way of associating something from a set X to something else in a set Y, where we take X, and that's going to be called the domain of the relation, and a set Y called the range of the relation. So in a relation, each element from the domain corresponds to at least one element from the range. So if X and Y are two elements in these sets, right, we're going to take X to be in the domain, Y to be in the range. And if a relation exists between X and Y, so there's something relating X and Y, then we say that Y either corresponds to X or that Y depends on X. And to represent that, we do X, Y, and an arrow to show that there's some sort of relation between X and Y. We can also group that up in a different way, and we can write X, comma, Y. So notice that the first letter, X, is coming from the domain, the second is coming from the range. Now, to restrict down to functions, the things that we will be studying, we're going to take X and Y to be two non-empty sets. So there's something inside of X, something inside of Y. Then a function from X into Y is first and foremost a relation that associates with each element of X. Now this is the important thing. Exactly one element of Y. So a function is a relation with a very special rule that says that for each element of X, so for one thing in the domain, there is exactly one element in the range that corresponds to it. So in other words, for a function, no input has more than one output. So for the domain of a function, that's going to be the set X, and the range of a function is a set Y. So take a second and think about this question here. Can an element in the range be repeated in a function? And why or why not? So going back up to the definition, it just gives a restriction on what happens to elements in the domain. No restrictions on the elements in the range. So going back to this question, can an element in the range be repeated? Yeah, there's nothing saying otherwise. And for why or why not, let's think of an example, our prototypical example of a function. We have y equals x squared. So x is in the domain, y is going to be in the range. The relation is that the value y is equal to x squared. And if we take, say, 1 and we square it, we get 1 back. And if we take negative 1 and we square it, we get 1 again. So this one and this negative 1 are coming from the domain, whereas this 1 is exactly the same, and that's in the range. So this value in the range is repeated. There's two elements from the domain that get mapped to it. Since we can view relations and also functions in these coordinates. This next example is asking us just to pick apart these three to see if it's a function. And if it is a function, we need to figure out what its domain is and what its range is. So again, a function, you can't have repeats in the first coordinate. So looking at this first one, we have a -2, a 4, a 3, and a 2. All of those are distinct, so this is a function. And for the domain, we just need to list out in set notation what the elements are of the domain. So we have a -2, 2, 3, and 4. And I like to list these in order, but it does not matter because a set has no particular order associated to it. Now for the range, that's going to be all the second coordinates. So we have a 3, 1, -2, -1. Let's do that in order. We have -2, -1, 1, and 3. Looking at this next example, again, it's a function if there's no repeats in the first spot of each coordinate. So we have a 2, a 4, 3, but then we have a 2 again. So this is actually not a function, because that 2 in the domain is associated to both 3 and to -1, which creates a problem. Moving over to this third one, we have a -2, 4, 3, 2 as the first coordinates, no repeats, so we are good. That means we are working with a function here. The domain, again, we have -2, 4, 3, 2. Going in order, we have -2, 2, 3, 4. And for the range, we have 3, 3, 3, -1. And since we're working with sets, we don't have any repeats. So in the range, we have a -1 and a 3. And that is our range here. And sometimes functions are given to us as equations. And we're asked to determine if the following equations define a function where we treat y as a function of x. And all this really means is, can we write y equals something with x's on this side? That's all that really means, to say y is a function of x. Looking at this first example, it already gives us y equals something for x, and so this is a function. And to kind of wrap your head around the definition, take any number for x, plug it in here, you will only get one value back out for y. So that satisfies the definition of a function. Let's look over here. Can we solve for y in this equation? If we started to solve for it, we get x minus 1 equals 2y squared. We'll divide the 2 over, and we're left with a y squared, but we want y by itself. So to get y by itself, we have to introduce the square root. But by introducing the square root, think back to high school algebra, you end up picking up a plus minus, because when you square either a positive or negative, it automatically goes positive. So we end up getting plus minus the square root of x minus 1 over 2. That's equal to y. Now this plus minus creates a problem. Right, so when you're evaluating this, if you just choose an x value and you plug it in, let's say we take the value x equals 3. And we plug that in, we get 3 minus 1 over 2. Doing the subtraction, we get 2 over 2, which gives us 1. Then we forgot the square root. And we also forgot the plus minus. Right, and the square root of 1 is 1. So what this tells us is that for when x is equal to 3, our y value is both positive 1 and negative 1. So if we write it as an ordered pair, we have 3, negative 1, and 3, positive 1, which the fact that 3 occurs twice is no good, so that's a problem. Which means that this right here is not a function.